All right, today we're going to be working on graphing linear inequalities with two variables. So earlier in the school year, we worked on graphing just inequalities, and we used those on a number line. Now we're going to be graphing inequalities with the y and the x value, so two variables. That's why it says two variables. It is similar to graphing them on a number line. Whenever we are graphing the dashed line, we are graphing like this, and that is because we do not have the equal to sign, so less than or greater than sign. If we have an equal to sign, we are graphing with a solid line when we connect the points. What this means is when we graphed our regular inequalities earlier in the school year, we had the open circle and closed circle. So it's pretty much the exact same thing. It's just this time, instead of a closed circle, we do a solid line versus the open circle, it's a dashed line. We are going to shade the part of the line that is a true statement. Now, this may not make sense to you, actually, me saying that right now, but as we go through the problems, I will get that explained a little bit better. Please make sure you're taking your own notes, so use a dual screen because this is something that we are going to test on Monday and Tuesday before Thanksgiving break, depending on if you're a Western or Miller day. So I'm going to go ahead and get started with this first one. It says, is the ordered pair a solution to the linear inequality? So all we're going to do is plug in this x value for x and this y value for y because it's an ordered pair. So we'll have 2 multiplied by 4 minus 3 times negative 1. And we're trying to figure out, is that greater than or equal to 5? So 2 times 4 is 8, and negative 3 times negative 1 is 3. So we end up with 11. And so is 11 greater than or equal to 5? Yes, it is. So this is a true statement. Essentially, when I said earlier, shade the part of the line that has the true statement, when we have 11 is greater than or equal to 5, and that's true, we would look at the ordered pair 4, negative 1, and see where that falls, either above or below the line, and we would shade the side of the line that includes that value. Again, we are not graphing it, so that does not come into play. Our next problem, we are going to do the exact same thing. If you want to try it on your own, pause it first, and then try it on your own, go ahead. So we have 3 is less than 5 times 2 minus 8. So 5 times 2 is 10, and then minus 8. So I have 3 is less than 2. 3 is not less than 2, so this is a false statement. Again, if I were shading this on my graph, then I would shade the side of the line that does not include the ordered pair 2, 3, because it is a false statement. All right, so now we're on to our first example, and our first example says y is greater than negative 2x plus 3. So this is already in slope-intercept form. Remember that we always graph our y-intercept first, which in this case is positive 3. So I'm going to go straight up 3 on my y-axis, and then my slope is technically negative 2 over 1. So what that means is I'm going to go down 2 and right 1. I also could go up 2 and left 1, but because my graph is a little messed up, I'm not going to do that at this point. So what I'm going to need to do is I am going to graph this with what we call a dashed line. So instead of connecting the points with a solid line, I'm doing dashed, and that is simply because my inequality sign is greater than, not a less than or equal to, or greater than equal to. Now, I'm going to have to figure out what side of the line to shade. So I can do this 2 different ways. 1, I can read the inequality. It says y is greater than the line. That's basically what that's saying. Y is greater than negative 2x plus 3. So y values that are greater than the line are going to be going upward. So when I'm going upward, that means this side of the line. Again, that's because I'm talking about y values are greater than the line, and greater values go up. So I would shade the right side of the line or the upper side of the line. The other way you can do this is you can pick any ordered pair on the entire graph that's not on that line. Typically, the easiest one to choose is 0, 0. So I'm going to plug in 0 for my y and 0 in for my x. So when I do that, I get 0 is greater than 0 plus 3. 0 is greater than 3. In this case, that is a false statement, and I have to shade the side of the line that is true. So since 0, 0 is below or on the left side of the line, I have to shade the right side or above the line. Again, both ways get us the exact same answer. Personally, I think reading the inequality is easier because you don't have to do extra math and things like that, but it does help to know that that is an option. Okay, so our next one, negative 2x plus y, is less than or equal to 4. So first thing I always do is I try to get it in slope-intercept form. So I'm going to add 2x to both sides. And when I do that, I end up getting y is less than or equal to 2x plus 4. So now I'm going to graph my y-intercept, which is positive 4. And my slope is positive 2, so up 2 and over 1. I also can go down 2 and left 1 because that's negative 2 over negative 1, which would give me a positive, a negative, negative. Now in this case, my line is going to be solid. And the reason for that is because we have an equal to sign on our inequality. So when I go to graph or shade this, it says y is less than or equal to this line. So values of y that are less than or equal to this line are going down. So since they are going down this way, I'm going to shade this side of the line. Now, if that doesn't make sense to you, you can always plug in any ordered pair that's not on the line. In this case, I would use 0, 0 again. And so if I plug in 0, is less than or equal to 2 times 0 plus 4, I'd get 0 is less than or equal to 4, which this is true. So I would shade the side of the line that includes 0, 0, which I did. So I am good to go. All right. Our next problem says y is less than negative 1/2 x plus 2. So what I would do here is that I would graph my y-intercept first, which is 2 in this case. And then my slope is negative 1 over 2. So I go down 1 and right 2. I also could go up 1 and left 2. That would give me a negative slope. Okay. And this is going to be dashed because it is a less than sign. So this inequality says that y is less than this. So values that are less than are going to be this way. So I'm going to shade in this. Also, if I wanted to plug in 0, 0 again, that's not on the line. So 0 is less than technically 2 because 0 times negative 1/2 is 0. And 0 is less than 2. Since 0 is less than 2, we will be able to shade that side of the line. All right, I'm going to skip this next one, letter D. I'm going to go on to letter E. So letter E here says that 2x minus 3y is greater than or equal to 6. So what I'm going to do is solve this for slope-intercept form. I'm going to subtract 2x to both sides. Then I will have negative 3y is greater than or equal to negative 2x plus 6. Now I need to divide everything by negative 3. When I divide everything by negative 3, you need to remember that you need to flip your inequality sign because you divided by a negative. So now it is less than or equal to negative 2 divided by negative 3 is positive 2/3 x, and 6 divided by negative 3 is negative 3. So I'm going to graph negative 3, which is my y-intercept first, and then I'm going to go up 2 and write 3, and I can go up 2 and write 3 again. This is going to be a solid line. And hopefully I can get this a little better than what it is. There we go. Okay. And now I have to decide what side to shade it on. It's saying that y is less than or equal to. So again, below. So I'm going to shade this side of the line. If I chose my ordered pair, 0, 0, and plugged it in, you can either plug it into the original equation or you can plug it into your other equation. It doesn't matter to me. I'm going to show you plugging it into the original just so you can see that. So 2 times 0 minus 3 times 0 is greater than or equal to 6, which that would be 0 minus 0, which is 0, is greater than or equal to 6. This is a false statement, so I need to shade the other side of the line, which does not include 0, 0, in which I already did that. All right, here is the last one I'm going to do for you guys. So this one says y is greater than 3/4 x minus 3. So I'm going to go straight down 3 for my y-intercept. And I'm going to go up 3 and over 4. And this is going to be a dashed line. Also, if you didn't know, if you hold down your choose your color, if you swipe to the left on the actual part, you can get a dashed line. So you can decide what you want to do with that. I just dash it myself. So here I have to decide which side to shade. So it says y is greater than this amount, so I'm going to shade this side of the line. Also, if you didn't understand that part, because it says y is greater than the line itself, if I plug in 0, 0, I would have 0 is greater than 3/4 times 0 minus 3, which is 0 is greater than negative 3. And 0 is greater than negative 3, so that's why we shaded that side of the line. Your shading doesn't need to be perfect, exact, just like that is completely fine. When you're using your pencil, you can just shade like that, scribble knowing which side of the line is being shaded. For your virtual learning tomorrow, you're going to be working in your workbook on page 161, 13 through 18 all. It's basically 6 graphs there, and you need to graph them, shade them, make sure that they have the solid line or the dashed line as well. And don't forget to shade. If you're having questions or need help with anything, please don't hesitate to email me or ask me. I hope to be back at school later today, so you can come and ask me questions if you need help. Remember that there will be a test next for you guys Tuesday, which will be just 5 short questions about graphing inequality.